So, before I start my session, what I want you guys to say is that I like interactive session. So, whenever you have question, you can just unmute yourself, or you can post your questions into the chat, and I'll be very happy to answer it. And whatever question I am asking within the presentation, I would expect from you guys to answer it via chat as well, right? So the more response I would get, the we both will, or we all will enjoy the session. Okay, cool. So let's start with the presentation. And just a second. Okay. So before just a second, let me s- sorry for interruption. I just need to do something. um, mm, okay. Mm, sorry guys again. Yeah. So let me share my screen again. Okay. Can you see my screen now?
Yes, we can.
Okay. Cool. So what I wanted to do is that and is it like a presenter view or a normal view?
Normal is also good.
Uh so it's not a double side, right?
Now it's a double side. Please,
Okay. Just a second.
this is the presenter now.
Okay. Uh, mhm. Okay. Anyways. So, okay, without a further ado, let's start with the session. And tomorrow I would be discuss about like Sentinel, which is a product from European Space Agency, which is a satellite mission, and they have a different products and how we will use those. How what are the consideration we should use to in order to use that, and also like how we can process and what kind of different tools are there in the market to process it. And then I would also talk a little bit, or let's say show a demo of us one single processing step with the softwares and with the Python API as well. Okay, cool then. So I'm skipping the introduction as you guys already know. So let's start with a question. For example, if I say that what is a sentinel? So what is the first thought pops up in your mind? What you think on this slide, whether A is a sentinel, B is a sentinel, or C is a sentinel? What do you think? It's a fun quiz, guys. You would like it. Um, yeah. Just a second. I'm not able to access the chats.
Oh, it's a very good question to all the participants. So, if you
And
are thinking A, okay, good.
yeah, if you are thinking C, if you are thinking good, good. So, what happening is just a second. I'm not able to access the chat, and then okay. So what I'm saying here is that all of these three images or all of these three are a sentinel. So if you consider about an option A is a sentinel island. If you know that in Indiana Ocean there is a one island which have been isolated for like many years, even when the modernization has started, these islands still have an isolated people who use who even haven't got vaccinated for polio, let's say, right? So they don't accept any people who are from outside or from the modern worlds, as they think that we are a threat to them to bring the diseases and ultimately which they are not immune for. So it's a very cool and interesting article. If you guys are interested in it, you can just Google it like Sentinel Island in Indiana Ocean, and you will find really very cool stuff about it. About the bee, it's also a sentinel. It's actually a movie, and it's a thriller movie which I haven't seen it, but I just saw the like a trailer and it's really nice. And then C is again a sentinel, which is the standard sentinel that is satellite. And fortunately or less unfortunately, we're gonna talk about the option C today, not option A or B. So yeah, it sounds boring, but don't worry, it's really very interesting as you go far. Okay, so what we're gonna do today, discuss today, is like the Sentinel mission, the Sentinel product, the Sentinels, what kind of like missions are there in the current uh, in the present scenario, what kind of products they provide, and how those products would use in what kind of applications. So if you are from agriculture background, water background, forestry background, maybe civil background, then we will discuss about like what kind of products you should focus, and then we will do like how you can process those product, and then we will do a short demo about that. Okay. So let's start with the Sentinel mission first, right? So Sentinel have been started. It's a French word like Sentinella, the Italian word Sentinella, and French word is Sentinelle. It means that the it have been invented in 16th century, and the meaning of it was like guarding something. Like for example, just like a security guard is guarding your building security, right? Is the same thing is that somebody is what keeping watch on something for every time. It's called sentinel, right? And so in current sentinel mission, let's say there are like two satellites are orbiting towards the earth. As you can see here, that there are two satellites are moving towards the earth, and ultimately up to certain time it will cover the whole globe, right? So now the whole globe is covered, right? Usually in traditional mission, there would be like let's say one sentinel, one satellite orbiting over towards the earth, right? But in sentinel missions, whether it's any kind of number of mission, it's sentinel 1, sentinel 2, there would be like two satellites is orbiting towards the earth. Now can anyone tell me like why two satellite, or what it could have been, uh, what it have might have provided? Can anybody tell me like why we need two satellite? Why don't only we need one satellite? Can anyone have idea about it? mm, any answer? I'm so sorry. Okay, yeah. Yeah, for twice data availability in a day, higher temporal resolution. Yes, correct. So for let's say for example, so why we do have two satellites is that it will increase not only the temporal resolution, it would also increase the spatial resolution, right? So it means that if two satellites are orbiting, right, obviously we will have more frequent images, but we will also have a comparatively higher spatial resolution, right? So let's say how many current missions are active right now, right? So there are like Sentinel 1, which is a radar based images, right? And this is a Copernicus 1.0 mission, and there are like total 6 mission, and for each and every mission there is satellite A and satellite B, right? And then in Sentinel 1, like let's say, so the current actively missions are like 4 missions, that is Sentinel 1, 2, 3, and Sentinel 5, right? And in Sentinel 1, there is like so Sentinel 1 mission is a day and night radar. So if you guys are very familiar with like uh, the radar data or microwave sensing, you can have the images over the land and ocean uh, in the night as well or in the day as well, right? The Sentinel 2 standardly operates on optical region, so that is like visible, near infrared, shortwave infrared, and usually those are used for land services because you cannot clearly see in the night. And then ocean services is really not, since it's not a hyperspectral much, you are, the limitation on ocean is like working studies on oceans is still limited. Sentinel 3 is a mix of both. So it's a radar altimeter, which will give you the information about the heights, and the optical sensing, right? It's standardly have the bands in visible and near infrared. And mostly they are used for marine monitoring. It's because their coverage is are more frequently on ocean, over the ocean area, open ocean area. Sentinel 4, they are planning to launch in near future, I guess, in couple of years. And they have, somebody have to mute yourself, I guess. Let me mute it. Who is that? Okay, okay, cool. Uh, okay, sorry, I had a question in the chat. Uh, Vikram, next time whenever I question, can you just pop in, because I'm not able to access the chat as soon as I present my slides. I don't know why.
So I think first we will conduct our session and at the end we will discuss about the questions. Is it okay with
Okay,
you?
okay, no problem.
Okay.
So for Sentinel 4, let's say Sentinel 4 have like light imaging spectroradiometer. So those are mostly would be used for, since it's operate on ultraviolet region, those are mostly planned for air quality monitoring. And considering on the air quality only, like there is currently a active mission which have been recently started to work, is like Sentinel 5, and usually we call it Sentinel 5P, which also works on a similar UNV spectrometer, and it's currently you can use for air quality monitoring. We will discuss further about its product. And then Sentinel 6, it's I guess it would be launched within the like radar altimeter. And they have the that would also be used mostly for ocean monitoring. So there is a quick quick fact about Sentinel 5P is that if you guys are following the Elon Musk or NASA or SpaceX, the Sentinel 5P have been launched with the NASA SpaceX Falcon vehicle. So it's a fun fact about the Sentinel 5. Okay, cool. So there are, these were the current missions. So currently we have 4 missions, and then the future there would be like 6 other missions which are planned after 2020. So they have just proposed it this year. So they would be launching around like in 5 years or within the next decade. So those are like Sentinel 7, 8, 9, 10, 11, 12. And majorly they are focusing on, again, the land surface temperature and the atmospheric property, the also the topography, because currently we have the good amount of freely available topographies like 30 meter from US. So they there is chances that we can have a higher altimeter around like polar ice and snow area also. The hyperspectral imaging, and also the polar imaging for the radiometer, like which would have more frequent temporal and spatial resolution. And also the L band radar. So currently we have the radar, it's like C band or Q band, but it's not L band SAR. So um, it would be very exciting if we would have this. And basically this Copernicus missions would be run by the TELS. So TELS is a private organization who designed these satellites, right? So you can check their website if you are more interested into that area. Okay, so let's start with the each and every mission now, and it's what kind of product it's provide, right? So in terms of Sentinel One, they provide basically 3 kind of measurements: geophysical measurements, polarimetry measurements, and inferiometry measurements, right? So it's basically nothing but it's like amplitude and phase. So amplitude is amount of energy you are reflecting back or not. In terms of SAR, it's not amount of energy, but it's number of pulses. right? And so in amplitude you record the number of pulses which you can convert into the backscatter, so which can be inferred as the amount of energy reflected back from the surface. And the inferiormetry, that is a phase information, right? So the phase information will give you like the idea about the surface deformation, or how the one object have changed its position in terms of height from one time to second other time, right? So that is basically inferiometry. And polarimetry is it's like a polarization, so how you are sending a pulses, in which direction you are sending a person and pulses, and how, which direction you are getting it back. That is a polarization, right? We will discuss it more about it, so don't worry. But standardly, like there is like three two polar like two mostly four polarizations are possible. It's like VV, so it's like you are sending the signal in vertical direction, you are getting the signal in vertical direction. VH, sending a signal in vertical direction, getting it in horizontal. HH, both receiving and getting the signal in horizontal direction. And HV, so it's like sending a signal in horizontal direction and receiving it into a vertical direction, right? There's nothing too hard to understand about, like nothing complicated about it. uh, but the more complicated is thing is that modes, right? So this mission gives you different modes of product. So before you choose the modes, and these are this mode base, there would be polarization information available, right? So first of all, how many modes are there? So there are like four more modes of acquisition modes. So over here you can see on the right of the image, there are like four modes. So let's start with the like strip map mode, right? So here you can see that the strip map mode is takes the images at around like 20° to 45° incidence angle. So that is the angle when you see from the ground. And you can see that the resolution is like or so let's say the one grid is like smaller, so it image over like a small segments, right? And mostly it would be used for like flood monitoring or earthquake analysis or landslide and volcano monitoring. And mostly these applications, it would be used for like mapping the small island. Why? Because whenever there is a small island, let's say, it will pass within the one go, right? So you would have an image with only a single pass. So as you seen earlier, in two satellites there would be like a two satellite would be passing, right? And that's why, let's say in India, if you need an image of whole India, you would require like multiple passes. So for few passes, like for few area, so let's start from Gujarat. So from Gujarat you would have image of, let's say, first of the month. Then on Madhya Pradesh you would have image of let's say third of the month. And then around, like, let's say you passes more on Seven Sisters, the images would be even more gap, right? I have more gap. But for small island, for strip map mode, you would have a very frequent images and within the one go only, right? Because those are small, and that's why you have whole image of the island in a one pass. So most probably the use of the S map mode is to cover over the uh, island studies. And usually, I guess, if I remember correctly, it's only provide a single polarization. It does not have a dual polarization, right? Then it comes to the inferiometry wide swath mode, right? So that is like IW mode, if you can see my cursor. And the width swath of sensing is 250 km. And I would go into the technicality of sensing, but what it does is that usually these is a very popular mode for studies over the land and ocean services. So it provides two polarization, that is VV and VH, right? And it's still not fully polarized. It means there are no four polarizations are available. But usually you can use it for any of the applications. So for sea or open like ocean ship, surveillance, oil pollution monitoring, marine studies, forestry, agriculture, urban, any of this, right? So you can see here. Because it does provide the data, or frequently we will discuss about its resolutions, but it's also provide a cross polarization, that is VH. So that's why, and then VV. So that's why it's very um, informative in terms of getting the information about the vertical structures because of the VV polarization, and also the cross structures because of VH polarization. Then we move to the wave mode. So where you can see here that it sends the image in a pixel basis, like in a small pixels, and then they have like 100 kilometer of width gap, right? And then they have like three incidence angle. So that is two are on 23 and one is on 36.5. And usually it would be used for like marine winds, or because it have a very low spatial resolution, it would be usually used over the ocean area only to usually map the wind speed and these things. Uh, and then there it comes like extra wide swath mode. So it have a swath of 400 kilometer, and usually it would be also used for ocean, over the ocean area, because it hardly have sensing on the land area, and it's also like a single polarization is available, right? So it has like the wave mode. If you are working on island, you can work on SM mode. If you are working in general, like you can use IWs for all. And if you are working only for oceans, then you can work with the extra width, right? Wide. Okay, so let's talk um about these modes and its availability, right? So for example, Sentinel will, as you have seen, that Sentinel will be, one satellite will be passing over the earth from north to south, and other would be from south to north, right? So from north to south it's called ascending, and south to north is called descending. So as you seen, as you can see here, ascending modes, right? Because the descending channels. But while there are like other countries, for example, whole European, they have both ascending and descending, right? And then there are like few countries, for example, over the Himalaya, you would have IW modes. So not all other modes would be, like for example, EW mode are not available. But let's say over the Indian Ocean, but let's say the IW mode have a single polarizations on ascending and descending both. So over here you would have dual polarization, right? So here IW mode dual polarization is available on descending over the India. But there are also other regions over the Himalaya where you have ascending and descending both, which provides you a singular polarization only, right? So this is how you can interpret this graph. It depend on your study, you can decide what kind of information you are available, right? And I highly would recommend you to visit the follow the forum of Sentinel, which is like forum.step.esa, where you can find this graph and you can decide what kind of information you want, right? I don't mind taking you screenshots of these graphs as well if you want to use it for your own purpose. I would only discuss for now today for the India only. Okay. So as I've said earlier, that these are the modes. Based on the modes, the different polarization is available, right? Now different polarization have also a different level of processing, right? So basically the raw data is not available to user, so you can just skip the whole raw data. But then in terms of this is level one product, which is called single look products. So single look product is like a look complex product, is SLC product, which are not processed product, right? So it's like the in terms of those are processed in terms of certain corrections. But then the single SLC products contain both phase and amplitude information. So it means that it contains both backscatter information and the height, surface height, right? While the GRD product, that is a ground range detected, which have been, and then SLC product would also have a products on different look angles, right? So as I have told you earlier here, that there would be like the one product would be of let's say 20 degree look angle, the other product would be 45-degree look angle, right? Here also it's like 25-degree, and here it would be something else, right? So those are like a different degree angle products you would have. Then you have to combine them, process it, right? And in terms of GRD products, those are basically already processed, and it's like a standard projected products where each pixel would have a similar size. So for example here, if you sense here, for example, this pixel would have a smaller area compared to this pixel, right? Because the look angle would increase, right? So height and width of the pixel would change compared to here. In SLC they are raw, but in GRD all pixels would have a similar size. So if it's 10 meter by 10 meters, so all pixels would have 10 meter by 10 meter, 20 meter by 20 meter, right? So for example, if you're not working with and then there would be level 2, that is the ocean mostly. So on level 2 products, like these are like a wind products which you can uh, yeah, depends on the what kind of information you want. So suppose for example, if you are working only with the, as I've said earlier, like with the ocean winds, right? You will have like OWN, so that is like ocean wind product with the extra wide, but then it's also available for IW, right? So depends on what kind of study you are working with. And the major difference I would say is that if you are working with only the surface structure, like surface change analysis, so then regardless of any field of study, you should use a Sentinel GRD products of Sentinel 1, because those are already projected and that only focus on backscatter energy, right? But if you are working on a height of the information, let's say or the surface deformation or earthquake analysis, or let's say soil erosion, then I would recommend you to work with the SLC product, because that gives you an information about how the soil component or soil structures have been changed in terms of height, right? Okay. So what kind of special resolutions are there? So it's not only the modes which are important, but the product type is also important, right? So let's consider about the IW1. So in IW1 extra, in IW mode, you would have SLC products, right? In a different angles, right? So as I've said earlier, and the resolution, the pixel spacing would also change from 2.3 meter to 14.1 meter, right? Based on the incidence angle and sensing, right? If you're working with GRD product, so in GRD product, it depends. There is a high resolution images of 10 meter by 10 meter. So basically what they do is they take these pixels and project it up to a single 10 meter by 10 meter pixels, right? And okay, so that would have like a 10 meter by 10 meter product. And how many looks they, so here you have one, so like this, these are the number of looks. So let's say you can see that here we have like 5 looks, right? 1 2 3 4 5 6. Oh sorry, it's strip, sorry, it's SM mode. So it's 1 2 3, right? So there are 3 looks, and there would be like 3 to 5 looks that would be merged over here. So here you have one image per each look, and here you would have like looks merged into a one single product, right? So depends on what kind of product modes we are using, and most probably the SM and IW have a special resolution. The GRD product special resolutions are 10 meter by 10 meter, but EW and wave modes have like little bit low resolution, that is 25 meter by 25 meter. Okay. So you can decide on what kind of look angle you want, right? And so let's say what is this pixel spacing, and what is their the let's say incidence angle based special resolution, and how many number of looks there would be. Okay. In terms of temporal resolution, so as I said earlier, that this is a very high like temporal resolution. So let's say here, in terms of descending, if you have images over 12 days, right? So over all over the India, you would have a 12 days images, right, over the descending mode. But all over the Europe, you would have 6 days, right, and also ascending, descending. But and same on 6 days, there are like part of a Himalaya and seven sisters, which would have images of every 12 days. Okay. uh, so that was the temporal frequency. You can decide which zone you are working, right? And then you can decide like what kind of images are available, what resolution you are. That also would impact on your guide, right? For example, if you're working with agriculture areas or vegetation area, you the 12 days resolution is fine. But if you are working with, let's say, um, earthquake data, or you're working with natural hazards, if you don't have the images over that particular time, then it doesn't make use of those images. So temporal resolution also depends on your field of your study. Same, let's start with the Sentinel 2 now. So Sentinel 1 is a little bit complex because it have a microwave sensing data, and it's have lots of complex in terms of what kind of look angle you want, what type of information you want, what type of modes are available within that, what type of polarization information is available, right? So these four things you need to consider very while you are working with Sentinel 1. So that is the first is the mode. Second one is the which type of product, SLC or GRD, what kind of polarization it provides, and where and what type of information it provides, right? Like temporal and ascending, descending. Okay, let's move to the Sentinel 2. And Sentinel 2 is, as I've said earlier, it's like optical sensing. So they have bands of two spatial resolution, 10 meter and 20 meter. And on 10 meter, they have images of standard channels, that is blue, green, and red. And that is one is near infrared, right? But then they also have the narrow bands. So on 20 meters, so here you can see is that these are called rad edge bands, right? So band 5, 6, and 7, and narrow band 8A over the NIR spectra. And then they have shortwave infrared at band 11 and band 12, right? So what makes this more important is that these band, red edge band of band 5, 6, and 7, it would allow you to use these Sentinel 2 product for for sensing for the vegetation. Why? Because this radar sense, if you are familiar with the spectral reflectance curve, you would have a sharp, so like usually the spectral reflectance curve um, something looks like this, right? So let's say this is the soil, and spectral reflectance curve something look like this, right? So this area from red to NIR, right? This area is the one who have a sharp increase or decrease. So suppose for example, if it's evergreen, it would have a sharp increase. If it's, let's say, a deciduous forest, right? So their spectral reflectance curve would be similar, but their spectral reflectance curve would be something like this. So the sharp increase is this one, right? So if you think about it like in other graph, the sharp increase is this for deciduous. However, for evergreen, it's this, right? So there are different vegetations who reflects differently, or that sharp increase is different in that red edge band. So that's why, and that is very sensitive to the vegetation only. That's why it will be used, it is very popular over the vegetation, using it over the vegetation area, right? Uh, so in terms of temporal resolution, all around the globe, it is available at 5 days temporal resolution. However, at polar side, it's available like 10 days. In terms of levels, so let's say there are like level 0, level 1A, 1B, which are not available to the users. So usually it's like the raw processing levels. But then they have level 1C, right? And level 2A. So depends on the image. So level 1C is the image which is not atmospherically corrected. But level 2A, it means that it have been atmospherically corrected, right? So as you can see here on the image, like level 1C, you can see a little bit of haze over this ocean, right? Also over the land area. And it could be like thin cloud or a little bit haze in the scene. So you can just process, you can convert it into a level 2A. In level 2A, after 2000, December 2018, you have level 2A images. But before, like, so Sentinel have been started in 2000, I guess if I'm not wrong, 2015. So you would have images from around 2016, 17. And so up to December 2018, you don't have level 2A product, right? So you have to do that manually. So for both of the Sentinel 1 and 2, we almost have the data up to now for like almost 3 to 3 years, because it have been started around 27. So I'm talking about both satellites, so A and B, right? So it would be around, like, now we have 3 years of satellite data, and it would keep continue. Now let's move to the Sentinel 3. So this is really not much popular, but it's very popular in terms of when you are working with ocean data, right? So let's say they have basically four products, right? That is ocean and land color instrument, so which is usually have a two spatial resolution images, that is 300-meter and 1.2 kilometer. It's a reduced 1.2 kilometers reduced resolution images. So they usually work over the like 21 spectral bands, right? But its resolution, due to the very low spatial resolution, that is like 300-meter to 1.2 kilometer, usually it would be work. And these bands also have bands over working over the ultraviolet regions, right? So that's why it's pretty much used full in atmospheric corrections data, or let's say climate studies, right? Because it measures the atmosphere around the globe, and the temporal resolution is also less than 2 days. So that's why it's very popular for the climatic studies. uh, the other product is SLSTR, so that is sea and land surface temperature, and they have also two special resolution, that is 500-meter and 1 kilometer, and it have 9+2 bands. So why 9+2 bands? I said is that, so the 9 bands are typically over the, like, it's called solar reflectance bands. So basically the visible, near infrared, and shortwave infrared. But they have two other bands, that is a fire active band, that is F1, F2 bands, which senses the which is very useful for mapping the fire activity around the globe, right? Or within these 9 bands, they also give you the sea surface temperature, right? Or it also gives, and since it also have a radar radiometry, it also give you the sea surface heights, right? That is like around 4 days temporal resolution, right? The third one is the synergy product, which is a combination of OLC and SLSTR, but usually they use, or they work over the visible and near infrared bands, so combinations of visible and near infrared over these two channels. And if you guys are working with Spot or Proba V, so they have like 300-meter resolution of everyday images, right? And mostly they would be used for vegetation. So synergy products are continuation of this Proba V and Spot vegetation for climate studies, or for vegetation studies over the global scale, because they have like low spatial resolution, that is 300-meter approximately, and higher temporal resolution, that is almost daily. The altimetry is 300-meter to 1 kilometer. So they have like two bands, that is in Q and C bands, and it depends on what kind of orbits they are. It gives you a resolution of 4 to 27-meter bands, but 27 days. But basically, it provides you sea surface heights, and the resolution is still not very good, like 300-meter to 1 kilometer. But it also gives information on like sea surface temperature. So usually these whole Sentinel 3 would be used for Sentinel for ocean monitoring, right? So the last one is the Sentinel 5P, and Sentinel 5P have usually called a tropospheric monitoring instrument, so tropomy, and Usually it works around like ultraviolet region, visible region, and short wave infrared region. So because of that, you can use it for let's say atmosphere monitoring. So usually you have a concentrations of ozone, sulfur dioxide, nitrogen oxide, carbon monoxide, methane, and formaldehyde around in the atmosphere. And usually the temporal resolution, as we will discuss it in the next slide, but the spatial sampling is like 7 by 7 kilometers square. So it's not so great spatial resolution, but for atmosphere parameter, it's quite good because the atmosphere doesn't change over very high spatial scale. So, however, it changed over very high spatial temporal scale, and which makes sense. So that's why we have a very high temporal resolution over here for Sentinel 5P. So, for example, here over all over the near the equator only, it's like 2.5 to 2 days, but all over the other globe, it is approximately uh, once on a day or once in a 2 days, right? Considering the India as well. So let's start with the application. So as I've while talking only, I've tried to mention which product to use for which application, but there are other certain good applications which you can uh, think about it as well. So for example, here you can see the oil spill using a Sentinel-1 product, right? So because the Sentinel-1 product backscatter value is very sensitive to the liquid water or oil on the surface, right? So which is not the case for Sentinel 2, Sentinel 3, and 5. So that's why whenever you're working with like a water moisture, soil moisture, or water content related studies or uh, things like that, then you can work with Sentinel 1. Here it's a very great example of oil spilling also, uh, or oil monitoring over the ocean. Then there is, as I've said earlier, that wave mode will be, you can able to use the map the wind speed directions and also the wind speed, right? So it depends on the vector direction and the speed. You can define, like you can monitor the um, cyclones. Ship monitoring, this is like it could be used with Sentinel 1 and Sentinel 2 as well, but I would say the Sentinel 1 have more higher potential because it have a very high drastic different dielectric constant between the water and the surface. So you can see the ship very accurately. In terms of agriculture, so as you have seen here, there's the Sentinel 2 product and over the same region Sentinel 1 product. So as I was mentioning earlier that both of the images, both of the missions can be used for monitoring agriculture, forestry, or urban area, or green spaces over the urban area. But the thing is, like sometimes the Sentinel 2 have a radish band. So like see for example over here, you can see the difference between like different type of vegetations, right? Like for example, these are looks like something uh, deciduous forest compared to these dark ones are like evergreen, right? But in terms of species, we still don't have the information. So what Sentinel-1 do is that it's also sensitive to the moisture content, right? So we can see here that these area overly similarly look similarly in like Sentinel-1 area, but if you see it Sentinel-2, sorry, in Sentinel-2 it looks similar, but if you see Sentinel-1, due to the moisture sensitivity, you can, and also the its sensitivity to polarization, that is vertical and vertical horizontal, you can see that you can also have a glimpse of moisture content within the canopy and also the canopy structure. So over here you can see that it have a higher dense vegetation compared to here they have lighter dense vegetation. Okay. Then there's also like using the Sentinel 3 or Sentinel 1 as well. You can map the the volcano ground motions, right? So how those have been using a single look complex, you can measure how the deformation have been happening around those active volcano region, right? Same with the flood, as I've mentioned earlier, that's in Sentinel 1. would also give you height of the surface. So if there's a flooded area, you would observe certain increase in the phase information, right? Same with earthquake deformation, as I've been mentioning earlier. um, So, in order to conclude in terms of applications and product, so let's say if you are working with atmospheric monitoring, you should work with Sentinel 3 and Sentinel 5P because they provide accurate data, and or let's say they provide the data which can be used for such application. For marine monitoring, you can use Sentinel 1 and Sentinel 3 because it provides the data over the open ocean space very frequently, and it provides the data like sea surface temperature, sea surface height, what are the colors of the oceans, right? So that's why it's very useful to study certain things. And Sentinel 1 is for wind. uh, then in terms of all Sentinel missions you can use for any of these applications. So suppose for example if you are in security, land monitoring, climate change, disaster management, so all of certain missions you can use, right? Depends on what kind of information your study is related. Okay, so in terms of Sentinel processing, usually what are the usual step is that first of all, you check what kind of mission you want. After you check what product you want, right? After you check what kind of product types are there, right? So suppose, for example, in terms of data access, you would have to check these things. So what type of mission, 1 2 3 or 5P, then what kind of level of product they have, right? And what type of product they have. Based on that, the pre-processing steps would be deciding. So considering an example of Sentinel 1, if you are working with SLC, right, you would have more number of pre-processing steps compared to GRD, because GRD is already processed. So for GRD, there is like just let's say converting it into the backscatter value and that's it, right? Or terrain correction and that's it, right? But for SLC, it's not the case, right? So it's a more complex data. So you need to work, the pre-processing steps would be more, right? And then there would be like analysis, uh, which would which depends on your study, and then post-processing, right? So that is like based on whatever the study you have, you you can again process your images or analysis. So these two part we will not discuss, but data access we have already discussed, and let's now discuss the data pre-processing. So in terms of data access, I've said that like what kind of data is available in terms of access, where you can find it. So let's say you can access it using Python API, you can access it using like Conda, you can access it using like Copernicus Open Access Hub, Google Earth Engine, right? There are also like Mundi services. So there are like other private and open source images websites you can use. Personally, if you are working very familiar with the JavaScript, I would suggest you to go with the Google Earth Engine. If you are familiar with the Python programming, I would suggest you with the Python API that is called Sentinel Set, right? I'm again saying it's Sentinel Set, SAT, right? So you can just import that one, install it in your Python, import it and work with it. If you are not familiar with any kind of programming, you can simply just go to the Copernicus Open Access Hub. You will draw your area and then you will access it. I'll show a short demo of it. So let's see. Uh, Before I do a demo of downloading images, let's we do a little bit discussion about on pre-processing. So if you are working with Sentinel API, they also have its packages to snap packages to process those images. If you are not familiar with programming, the Snap is also is a software which is provided by Sentinel Mission, so you can use it for processing the images. We will show a demo of Snap today, right? I will also try to show you a code over the Python, and Sentinel toolboxes are also there. So you can, I'll also show a demo of Sentinel toolboxes. You can just install and use it as a command line operator. There is also certain GitHub packages, right? Or these, there are also like other Sentinel Hub is the also an API to use it to in order to do the processing steps, right? So let's see that. So I'm not going into Sentinel 1 pre-processing because it's really very complex and very hard to cover all in a 1 hour. But let's say, let's start with the simpler version of pre-processing, that is the Sentinel 2. Whereas I've already showed you the image of uh, Sentinel LN level 1C versus level 2A. So that is the atmospheric corrections of the images, right? So before I move to that, let's first start with how you can download the images, right? So let's say I was, as I was mentioning earlier, that sign, uh, oh, sorry. So over here, you can see that you can just simply go to the Open Access Hub, and then you can simply, so these are the API hub. You can know that what kind of APIs are available, right? So the website is scienhub.copernicus.eu, and on Open Access Hub, let's say, uh, you can go wherever the place you want, right? So let's say we go to the somewhere around Maharashtra, near Mumbai, and we can select our area of region. So let's say this is our area of study, right? It could be also big, I don't mind, but depends on your area of study. Then here are the missions. So first you decide what mission you want. So that is Sentinel 1, Sentinel 2, or Sentinel 3, right? Let's say, I would say, like, let's say Sentinel 2, right? If it's a Sentinel 1, you have to decide like whether you want A, B, keep it blank if you want both. What kind of product? So let's say single look, GRD, ocean, or raw. So in certain Sentinel, there are like raw products are available for oceans. So, but usually the single look, GRD, and oceans are the more popular one. In terms of polarization, which polarization you want? So this is the one which is available around the IW mode, which is VV and VH, and then also like which mode you want, right? So IW, SM, EW, wave mode. In terms of Sentinel 2, it's only like with satellite, so I keep it blank. Product type is like you want uh, SLC1 or L2 correction, right? Or this is also L2 correction. And if you want certain cloud cover, that you can also add. So let's start with the SLC1. So not SLC, level 1C product. And let's just simply search it. So you need to uh, log in into the one. I hope I remember my password. Oh, okay, I didn't. Uh, okay, so as soon as you just click on the search button, it will give you all the list of the images. You can also, like, since I have not sensed the I have not mentioned the sensing period date, right? So if you have looking for images for up to certain range of the images, you can also check it. So approximately from 2017, you should be good to have both satellite images. And yeah, and here let's say, so let's say here you would have L1C products, right? And you can see like where it is. So you can see this one is for approximately this mode, right? And then if you like it, you can simply just download it, right? You can also like read more about its metadata. This is also like downloaded URL. I won't go into the like details, but this is the one which I'm mentioning here. So you would have like the name and everything, and then like metadata of the product. So this have cloud coverage percentage of 0 and other things. You can check. So this is like 4th of 17th of April. So yesterday's image, right? And depends on which image you want. You can click around and then you can check. Okay. uh, the other way to access it is that usually I access it using Sigwing. So it's like a Python API. So as I was mentioning earlier, that you can simply just, sorry for uh, yeah, so usually I go with like a Sentinel set, and then which I define the parameter in the command line, and then I download it, so I don't go to the software one. But you can do the both, depend. Let me also show you the if it will take time a little bit. So meanwhile, let's see how does, and whenever you download the image, how does it look like, right? So let's say uh, I'll show you in my drive. Okay, let me connect my drive meanwhile. Mm, okay, so here, whenever you download the image, it would look something like this, right? So this folder would appear whenever you download the image, right? So it's not a single image, it's a whole folder. Within the folder, you can see that says Sentinel 2B L1C product of 2021 uh, February 20, right? And this is like number of row and the orbit. So usually the folders are in .safe format, right? Within that, if you want to find an images, usually the images are like within the granular image data, and you would have like uh, these images, right? So these are like a 10-meter data. So these 1, 2, 3, 4 would be 10-meter, 5, 6, 7, and 8A would be 20-meter, right? 8 would be 10-meter. So these are the bands, but usually like how do we open it in terms of Snap? So you can simply just go to like a uh, to the designated folder. So let's see here, and you can open the folder and you can bring this L1C XML file. You can open the product, and it would take a little bit time. Okay, so it's here. It would have the metadata and everything, which I would not go to the each and every detail. But let's say let's open the RGB image. So it's already like you can just click on RGB window and it's already there. So this is how our image look like, right? Now you can see here that the image does have a little bit haze on it, right? It's like a thin haze, right? Even though the cloud is not there, but it's not, it looks like a little bit blurry over certain areas, right? So what you need to do is you can simply just go to the optical, and within the optical there is a processor called sense2 core processor, which you need to download it, right? As soon as you go to the sense2 core product, you can select your product, that is like L1C, and you can select the which kind of resolution you want, whether all, but I would do it right now for 60-meter because it would take a very long time. Meanwhile, when it's running, what we can do is the other use, as I was mentioning earlier, so you can just install the sense2 core processor in terms of like using the Python, right? And let's say, so here you also see that it's also using somewhat the background of the Python, right? And it would take time. So what the other things are, way to you to access it is that uh, let's say I go where my batch processing is, right? So let's say here is the uh, guide where I have installed my within the snap. This is my sense2 core processor, right? Within that, if I say that L2A underscore process, right? So this is the command also which we can work on. So what I'll do is simply I just do L2A process. Then I can simply just give my path. So this is where my files are. and this is my folder name. So I'm just copy pasting it, right? And then you need to define which resolution you want. So here you can see it says dash dash resolution, and then you need to specify. So let's start with the resolution 60, right? Oh, okay. This is happening is because it's also working over here as well, right? So over here also it's working. But let's say we cancel this one, right? And it would also last time in webinar also it took a lot longer time. So let's start with this only. Uh, so uh, let me do the steps again very quickly. So we go to where our processor is, and we go to L2A underscore process, then our product, right? And resolution 60. Oh, okay. It takes oh, okay. Last time also this happens. It's because I've already started on that one. Now that session haven't will take time to terminate a little bit. But let me hmm, let's see if I had it from last run. I won't have it. Yeah, I won't have it because it was using the same operator. Uh, okay, what I can do. So what happened in this here is that since I have an initial, so both of the processor use the same processor, the software one and the command line one, and this is because of the software updates in these Sentinel Snap. So because this folder have been already started created by the software, it won't happen again. So let me delete this folder, right? And now let me, sorry for a technical hiccup. Um, why I'm preferring it to go with this one, because this would, while we are taking the question, this would work faster compared to the one on the software, because in last webinar it also took a time. Okay, now it should work. Yeah, okay. So now it's working. Let it complete up to like 100%. It would take a couple of minutes. So, and then we will open it, right? And now it have started already. Okay, cool. So we will open that as soon as it will be atmospherically corrected. We will open it here again, and then we will check how it works. Meanwhile, let me show you a small thing if I still have it here. Uh, yeah, so as I've mentioned earlier that if you have Sentinel Sat API, you just install it, and then you can also query whatever your data is. So like date, time, product, cloud core percentage, and everything else, right? And then processing can also be done within that one, so which I really don't have it here. But usually you can use whatever the processing you are doing in Snap, you can do it in Python as well. Um, okay. Is there anything else? I guess for if you have guys have more query in terms of technicality, we can go more deeper, and else we can do a question round. Meanwhile, it's processing. So yeah, Vikrant, I guess we are open to the questions now.
Am I audible to you, Manushi?
Yes. Yes.
So, for the questions, first question is,
Uh, I guess it
first,
is the
yeah, so first question we can take, yeah, how it will enhance spatial resolution. So I think the question is related to the Sentinel data. So how Sentinel data will enhance spatial resolution?
So as you have seen in this talk is that the Sentinel-1 and Sentinel-2 have a spatial resolution of 20 meter and 10 meter as well, right? So how it can improve the spatial resolution is that since there are two satellites orbiting over the Earth, right? So usually what is the challenge is that if satellite is moving very fast, right, then we have low spatial resolution because it doesn't have much time to cover on the ground. But if a satellite is moving on the same pace, right, on every 5 day, but it it can take a more time to spend on that ground sensing, right? If, I don't know how if you are understanding this or not, but what I mean to say is that suppose, for example, if I'm saying that you can take there is a ground of 1 kilometer and I'm telling you to run around the ground, right? So if I'm saying it that you have to run around the ground of 1 kilometer within the 5 minutes, right? So what you would do, you would choose a bike, right? And you would do a cycling over that 1 kilometer ground, right, rather than walking. So when you are cycling, you are missing out the detail around the grounds, right? Like what kind of trees are there or what kind of surroundings are there. But if I'm saying that, okay, two people are moving with the same ground and one person have to walk half a kilometer within the 5 minutes, right? So both have to complete the 2 kilometer. So now you would not choose a bicycle, you would go with the walk, right? So one person would walk half kilometer, other person would walk half kilometer, and then you would meet with the one center point. Now while walking you're not missing out the details, because while walking you can see what is surrounded by you, right? In the same thing, that whenever two satellites are there, it obviously improves the temporal resolution, but then it also have more time to sense around the ground. So that's why the spatial resolution will also increase. Okay. Before we do another question, so this have been successfully like processed. So let's open it, and so this is, you can see that L2A image have been processed, and let's open the L2A one as well. Let's open the RGB. Okay, so here what you can do is, let's see here, like suppose for example you see here that this is our uh, processed image, and this is our not processed image, right? Atmospherically corrected. So you can see that even the resolution is different because this is 10 meter and this is 60 meter, but still you see that these haze around this area, let's say these area have been changed, see, right? So like see over here as well, right? So yeah, so it depends on what kind of things you want. There are lots of other things like there are also, they have a very good processor in terms of radar, in terms of optical as well, like different processor for different applications, and these you can also access it via Python. So yeah, so I guess that is it.